Hello, in this section, we will focus on counting techniques that involve permutations. Specifically, permutations involving distinct objects with repetitions not allowed. The number of permutation of n objects taken r at a time is given by the formula NPR equals n factorial over n minus r factorial. So please note that in this case, order matters. An object cannot be repeated. Objects are distinct. So let's look at some examples. Let's consider this example. How many ways can the letters of the word orbit be arranged if all the letters are used without repetition? So we know that in the word orbit, there are 5 letters. Once a letter is used, it will not be repeated elsewhere on the word. Also, you can see that the order is important. So you can see that this problem or the situation represents a permutation involving 5 letters. So the number of ways that the letters of the word orbit can be arranged is 5p5. So 5p5 equals 5 factorial divided by 5 minus 5 factorial, that is 120 over 0 factorial, that is 120 over 1. It's 120 ways. So the number of ways that the letters of the word orbit can be arranged is 120. And remember, this is a permutation problem. Order is important. And once a letter is used, it will not be repeated. Then let's look at another example. 3 students are chosen from a class of 39. One will get an A, one will get a C, and the other will get an F. So the question is, in how many different ways can these 3 students be chosen? As you know, the 3 grades A, C, and F are representing a specific order. So grade A, the first position, grade C, second position, grade F, third position. So you can see that this given situation is also a permutation problem and order is important. So the number of ways that the 3 students can be chosen is 39p3. So 39p3 equals 39 factorial divided by 39 minus 3 factorial, that is 39 factorial divided by 36 factorial. So to simplify this, we can rewrite this as 39 times 38 times 37 times 36 factorial over 36 factorial. So these will cancel each other. So the final answer is 54,834. So the number of ways that the 3 students can be chosen is 54,834. Let's look at one more problem. 3 cards are drawn one at a time without replacement from the standard deck of 52 cards. In how many ways can exactly 3 hearts be drawn? So you are familiar with the standard deck of 52 cards. You know that there are 13 spades, 13 hearts, 13 diamonds, and 13 clubs in this deck of 52 cards. So our question is, in how many ways can exactly 3 hearts be drawn? And also note that 3 cards are drawn one at a time without replacement. So you can see that the order in which the cards are drawn matters, and repetitions is not allowed, since one Once each card is drawn, it cannot be drawn again, right? Also, the 3 hearts that are drawn are distinct. So the given problem is a permutation problem, order matters. So the number of ways can exactly 3 hearts be drawn is 13p3. So 13p3 equals 13 factorial divided by 13 minus 3 factorial, that is 13 factorial divided by 10 factorial. We can rewrite this 13 factorial as 13 times 12 times 11 times 10 factorial over 10 factorial. So 10 factorial in the numerator and denominator will cancel each other. And the final answer is 1716. So the number of ways can exactly 3 hearts be drawn is 13p3, that is 1716.